Hi, before we talk about RAG, we must understand a very important limitation of large language models. Large language models do not know things in the way humans do. They do not query databases, access live systems, read your private files, and update knowledge automatically. They generate response based on pattern learned during training, statistical probability, and context provided in the prompt. That means LLMs are powerful pattern predictors, not knowledge engines. So let's understand the core limitation of large language models LLM, why hallucination occurs in LLM, why prompt engineering alone is insufficient. Large language models like GPT work mainly as pattern predictors. They generate the most likely next word based on training data and the prompts, not by knowing or verifying facts. By default, they do not query live databases, don't retrieve current information, and cannot access private company repositories unless we explicitly connect them. They also do not update themselves automatically, so they can easily become outdated on things like HR policies, company rules, or internal procedures. A key risk is hallucination. When the model is not sure, it may still produce a confident answer, including made up citation or invented company rules. That creates real enterprise risk, misinformation, regulated non-compliance, and inconsistent decision supports. For example, if an employee asks about a newly updated expense reimbursement policy, a standalone LLM might give old or incorrect steps. So why hallucination occurs in LLMs? Let's understand it. Hallucination happens because LLMs generate text by predicting the next token from training patterns. They do not verify facts again against an external source. When information is missing or the model is uncertain, it still aims to sound fluent and confident. So coherence can beat accuracy. That is how we get fabricated citation, invented policies, or detail that simply does not exist, especially risk in HR, legal, finance, and healthcare. For example, ask about a company leave policy. Without access to real documents, the model may fill in clauses using generic HR patterns. Why prompt engineering alone is insufficient? Let's understand it. Well, prompt engineering improves how we instruct an LLM, but it does not remove the model's core knowledge limits. Even advanced prompting, chain of thoughts, role prompts, structured templates cannot ingest large domain knowledge into the model. In enterprises, knowledge lives across thousands of changing docs, HR policies, SOPs, compliance manual, tech guides, and you cannot fit that into a prompt due to context window limits. Prompts also cannot guarantee factual correctness, real-time updates or automatic retrieval from internal systems. For example, a prompt won't magically include a newly updated cybersecurity policy or latest product catalog changes. It also does not scale. Every new scenario needs prompt tweaks, and user cannot be expected to craft perfect prompt every time. So now let's see the limitation of fine tuning for dynamic knowledge. Limitations of fine tuning for dynamic knowledge. Let's understand it. Fine tuning can embed proprietary knowledge into an LLM, but it's often impractical for enterprise use. It is expensive, requires significant compute time and specialized expertise. Any change in internal docs like HR policies, compliance updates, product info would force repeated tuning cycle, creating operational bottlenecks. There is also a risk of knowledge interference. Tuning can override or degrade existing capabilities if not done carefully. Versioning become hard. Regional or department specific policy variant may require multiple tune models, which is difficult to manage. That is why enterprise prefer a more flexible approach, update knowledge instantly without retraining, and keep transparency. So now how RAG work? Retrieve, augment and generate. Let's understand it. RAG, retrieval augmented generation, improve LLM answer by bringing in relevant external knowledge at query time. It runs in three steps: retrieve, augment, and generate. Retrieve, we embedded the user's question into a vector and do not semantic search in a vector database of index enterprise docs. We pull only the most relevant chunks like HR policies, SOP section, manuals, or KB articles. Augment, we inject those chunks into the prompt so LLM has authoritative context it didn't have before without fine tuning. Generate the model answer grounded in that evidence, which reduces hallucination and improves factual consistency. That is why RAG is scalable and cost effective for HR boards, support assistant, compliance tools and agent workflows. Now we will see the end-to-end RAG system architecture. End-to-end RAG system architecture. Let's understand it. A complete RAG system is an end-to-end pipeline to produce reliable, knowledge-grounded answer in enterprise settings. It starts with a user query that an embedding model converts into a vector representation. That vector is used for semantic similarity search in a vector database. We retrieve the top relevant chunks based on meaning, not just keywords. Those chunks are assembled and injected into LLM prompt as augmented context. The LLM then generate a response grounded in that evidence. So the answer is synthesized, not just copied like traditional search. This fits modern enterprise AI because the knowledge source, HR system, KB article, product docs can be continuously updated. Now let's see the key differences between RAG and fine tuning. RAG and fine tuning solve different problems. They are not interchangeable. Fine tuning bakes knowledge into model weights, which make it static, hard to update. RAG keeps the base model unchanged and pulls external knowledge dynamically at inferences time. That means RAG can reflect real-time docs changes, policy, legal updates, operational data without retraining. Transparency is another key difference. Fine-tuned models cannot reliably set source while RAG can show the retrieved evidence. So let's see the enterprise use case HR board with and without RAG. In enterprises, RAG makes AI assent far more reliable, especially in HR, where accuracy and compliance are non-negotiable. Without RAG, an HR bot may answer uh, parental leave questions using generic HR pattern. So it can sound right but be wrong. That creates real risk, misinformation, employee dissatisfaction, and potential legal exposure. With RAG, the system retrieves the exact relevant section from HR handbook or policy database, injects into the prompt an answer from evidence. So how RAG enable knowledge aware agents? Let's understand it. Agentic AI means autonomous system that can reason, plan and take action to achieve goals. Without RAG, agents rely only on what is inside the model weight, so they can act on outdated or incomplete information. With RAG, the agent retrieves relevant docs, policies, or step by step procedures before acting. So, decisions are grounded in the latest data. For example, an IT service agent can pull technical documentation or system logs before recommending a fix. Similarly, a procurement agent can reference updated vendor contracts or pricing sheet before making decisions. So, RAG versus fine tuning, eliminating common misconception. Let's understand it. So, a common misconception in that RAG and fine tuning compete or do the same job. They don't. Fine tuning mainly changes model behavior and tone, but it does not provide dynamic knowledge updates. RAG injects external information at inferences time without changing model weight. That makes RAG more flexible, scalable, and cost effective for knowledge heavy use cases. So, don't expect fine tuning to replace document retrieval or real time updates. RAG also improves transparency. You can validate answer using retrieved evidence, unlike fine-tuned knowledge buried in weights. So key takeaways are understanding the distinction help teams build AI systems that are accurate, maintainable and enterprise ready. So see you in the next video. Thank you.